In a world where the laws of physics reign supreme, Nvidia, a titan of technological innovation, has launched a game-changer, an AI chip that not only breaks boundaries but transcends them. How does this advancement challenge the fundamental principles of physics? And what implications does it have for the future of artificial intelligence and beyond? Join us on this thrilling journey as we unveil Nvidia's groundbreaking AI chip that defies physics. But before we begin, don't forget to like and subscribe to the channel. Nvidia, unveiling the future of artificial intelligence. Only 4 companies worldwide have reached the staggering market value of over $2 trillion. Microsoft, Apple, Alphabet, the parent company of Google, and now, the computer chip manufacturer Nvidia. Based in California, Nvidia's market value skyrocketed from $1 trillion to $2 trillion in just 8 months. This surge was fueled by the relentless demand for its cutting-edge technology, driving the current AI revolution. It's fascinating how a company founded in 1993 to enhance video game graphics has transformed into a 21st-century AI powerhouse. In March 2022, Nvidia introduced the Hopper architecture, specially designed for data centers and powering AI accelerators. The launch of Hopper generated immense excitement in the AI community, and demand for these products soared during the AI boom in 2023. Due to shortages and overwhelming demand, customers faced a waiting period of 36 to 52 weeks for H100-based servers to be delivered after ordering. Remarkably, Nvidia reportedly sold an impressive 500,000 H100 accelerators based on Hopper in just the third quarter of 2023 alone. Nvidia's unmatched position in the AI market with its Hopper products played a key role in the company's market capitalization. Named in honor of esteemed American mathematician David Blackwell, the Blackwell architecture pays tribute to his groundbreaking work in game theory, probability theory, information theory, and statistics. These mathematical domains have greatly influenced the design and training algorithms of generative AI models, which are based on transformers. A notable fact is that Blackwell holds the title of being the first African-American academic to enter the prestigious National Academy of Sciences. During a presentation to Nvidia researchers in October 2023, the company revealed its updated plans for data centers, now including references to its B100 and B40 accelerators, along with the new Blackwell architecture. Previously, the successor to Hopper was simply called Hopper Next in planning. Then, on March 18, 2024, at the Graphics Technology Conference, the GTC, Nvidia made the official announcement of the Blackwell architecture. More than 11,000 enthusiasts, including software developers, tech magnates, and satisfied shareholders, gathered at the Professional Hockey Arena in San Jose for a lively 4-day AI event. All eyes were fixed on one man, Jensen Huang, the CEO of Nvidia. Huang explained that Blackwell transcends being just a chip. It is a comprehensive platform. Although commonly associated with the production of graphics processing units, GPUs, Nvidia has pushed beyond the bounds of conventional design. Hopper is the pinnacle of GPU advancement currently, with Blackwell at its core. Hopper boasts an impressive 28 billion transistors, but what really sets it apart is its architecture. For the first time, Nvidia seamlessly fused 2 chips, creating a unified chip that communicates at an incredible speed of 10 terabytes per second. No memory issues hinder its performance. It operates as a single powerful chip. When faced with skepticism about Blackwell's ambitious goals, Nvidia remained relentless, resulting in this innovative chip. Blackwell integrates seamlessly into 2 system types. The first aligns perfectly with Hopper, facilitating upgrades, while the second, showcased on a prototype board, demonstrates its formidable power and future accessibility. Imagine a setup with 2 chips and 4 Blackwell dies connected to a Grace CPU via ultra-fast connections, a setup poised to redefine computing. According to Huang, what's truly remarkable about this computer is that it's the first of its kind, amassing an incredible amount of processing power in such a small space. Yet to further push the boundaries, Nvidia needed a series of new features that could challenge the laws of physics. Enter Nvidia's latest invention, the 5th-generation NVLink, housed within the new Transformer engine. This engine, twice as fast as its predecessor Hopper, features compute capabilities within the network itself, Why is this crucial? Well, when you have multiple GPUs working together, they need to share and synchronize information. Having extremely fast connections and the ability to perform computations within the network allows us to significantly enhance performance. Although rated at 1.8 terabytes per second, its effective speed even surpasses that, making it many times faster than Hopper overall. Compared to Hopper, it offers 2.5 times the training performance per chip, thanks to its new FP6 format. Moreover, it introduced FP4, doubling the capacity for inference tasks. This is crucial for saving energy, reducing network bandwidth, and optimizing time use, which will be extremely beneficial in the future of generative AI. Nvidia has dubbed this era of AI generative because it marks a significant shift in how we compute. The new Nvidia processor is tailor-made for this era, with a key feature being the generation of content tokens. Facilitated by the FP4 format, this chip, housed in the Nvidia Blackwell AI supercomputer, offers 5 times the token generation and inference capacity of Hopper. But why stop there? Nvidia is not content with just this level of performance. That's why they embarked on building an even larger GPU, surpassing the capabilities of the current one. The NVLink switch, revolutionizing computing. The NVLink switch is an incredible chip with 50 billion transistors, nearly the size of Hopper itself. With 4 NVLinks, each operating at 1.8 terabytes per second, this chip allows each GPU to communicate with another at maximum speed simultaneously. It's a groundbreaking advancement that expands the limits of what is possible in computing. With it, you can build a system like this. This is the latest iteration of the DGX, a significant leap from what it was just 6 years ago. At that time, the first DGX-1 boasted a modest 170 teraflops, or 0.17 petaflops. Returning to today, Nvidia is planning a performance of 720 petaflops, nearly reaching the milestone of 1 exaflop for training, a monumental achievement. This is the world's first exaflop machine condensed into a single rack. To put that in perspective, the exaflop machines around the world at this exact moment can be counted on one hand. This DGX is not just any AI system. It's an exaflop powerhouse compacted into an elegant rack. Now let's delve deeper into what makes this remarkable feat possible. The backbone of the DGX is the NVLink spine, boasting an astounding bandwidth of 130 terabytes per second. To illustrate its prowess, consider that it exceeds the combined bandwidth of the entire internet. This feat is achieved without the need for expensive optics or transceivers, saving a significant amount of energy, 20 kilowatts to be precise. In a rack that consumes a total of 120 kilowatts, each watt saved makes a significant difference. But what about cooling? Have no fear, as this DGX is liquid-cooled, maintaining a comfortable temperature of 25 degrees Celsius during operation. What goes in as room temperature comes out as the water from a cozy jacuzzi at 45 degrees Celsius. With a flow rate of 2 liters per second, this cooling system ensures optimal performance without overheating. Now let's shift our focus to the heart of the system, the GPU. While some might imagine a GPU as a simple component, for Nvidia, it represents much more. Gone are the days of bulky GPUs. Today's AI processing GPUs are complex marvels, composed of an astonishing 600,000 parts and weighing a shocking 1.3 tons. An incredible feat indeed. Now imagine training a GPT model with 1.8 trillion parameters. Previously, this task would take 3 to 5 months with 25,000 amps. With the Hopper, it would require about 8,000 GPUs, 15 megawatts of power, and roughly 90 days. However, with the Blackwell, the same task can be accomplished with just 2,000 GPUs and only 4 megawatts of power, a remarkable achievement in efficiency and performance. Blackwell is poised to become Nvidia's most successful launch to date, and the anticipation is palpable as we venture into the realm of Nvidia robotics. Nvidia has plunged into the fascinating world of physical AI, where machines interact with the tangible world around them. Until now, AI was confined to the digital realm, processing data within the boundaries of a single computer, like the DGX system. But imagine a future where AI transcends these boundaries, where robots possess their own intelligence and navigate real-world environments independently. It is in this context that a high-impact launch, like the emergence of ChatGPT, could occur in robotics. Nvidia has been working diligently on developing complete systems for robotics. This includes its AI powerhouse, the DGX, developed for training models, and the AGX, the world's first robotic processor, designed for high-speed sensor processing in low-power environments. Bridging the gap between the digital and physical worlds is the Omniverse, Nvidia's virtual world simulation engine, hosted on the Azure cloud. It's a fully autonomous warehouse brimming with activity, where humans and forklifts interact seamlessly under the watchful eye of the warehouse monitoring system, serving as a sort of ultimate air traffic controller. This intelligent system ensures the safety of all, directing traffic and providing guidance throughout the warehouse. And yes, you can even talk to this futuristic warehouse. And there's more. All of this operates in real time. Each robot is equipped with its own set of autonomous robotic technologies, making the entire process efficient and seamless. With Blackwell leading the way, the future of robotics is within our grasp. So let's delve deeper now into the wonders of robotics. The future of humanoid robotics. The realm of robotics seems imminent and inevitable in several sectors. It's a safer and more convenient option. Among them, the automotive sector is poised for a significant transformation. Next year, Nvidia will collaborate with Mercedes, followed by Jaguar Land Rover, to integrate its cutting-edge technology into these production lines. Huang also announced that BYD, the world's largest electric vehicle company, will adopt Nvidia's latest innovation, Thor. This next-generation AV computer, designed for transformer engines, will drive the future of robotics, potentially reaching humanoid robots. In a groundbreaking move towards advancing humanoid robotics, Nvidia has launched Project GRUT, a pioneering initiative created to redefine the landscape of robot learning. Going beyond mere imagination, Nvidia is delving into the realms of invention and exploration, pushing boundaries to unlock the full potential of humanoid robots. Project GRUT represents a critical leap in the field of robotics, offering a comprehensive foundational model capable of processing multimodal instructions and previous interactions. This model, equipped with sophisticated algorithms, allows humanoid robots to autonomously determine their next actions, bridging the gap between human commands and robotic execution. At the heart of Project GRUT is the Isaac Lab, a specialized robot learning app developed by Nvidia. Leveraging the power of the Omniverse Isaac Sim for simulation, the Isaac Lab provides a virtual training ground where humanoid robots can refine their skills and adapt to various real-world scenarios. Complementing the Isaac Lab is Osmo, a new computing orchestration service that seamlessly coordinates workflows across Nvidia's advanced DGX and OVX systems, ensuring efficient training and simulation processes. One of the most notable features of Project GRUT is its ability to learn from a minimum of human demonstrations. By analyzing just a few human interactions, humanoid robots equipped with Project GRUT can skillfully assist in daily tasks and mimic human movements with astonishing accuracy. This innovation is made possible by Nvidia's cutting-edge technologies, which utilize advanced neural networks to understand human behavior and translate it into actionable instructions for robots. Moreover, Project GRUT allows humanoid robots to generate movements based on natural language instructions, further enhancing their versatility and usability. Whether greeting or performing complex maneuvers, humanoid robots developed with Project GRUT demonstrate an unprecedented level of intelligence and adaptability. Powering the capabilities of Project GRUT are the new Jetson Thor robotic chips, meticulously designed by Nvidia for optimal performance in humanoid robots. These chips serve as the backbone of Project GRUT, providing the computational power necessary to bring humanoid robots to life and propel them into the future of robotics. As humanoid robotics continues to evolve toward greater autonomy and capability, Project GRUT remains at the forefront of innovation, paving the way for a new era of AI-based robotics. With Nvidia's unwavering commitment to excellence in software development and cutting-edge technology, the possibilities for humanoid robots are limitless, promising a future where robots seamlessly integrate into our daily lives, revolutionizing industries and the way we interact with technology. Now, let's delve into the fascinating journey of how Nvidia evolved to become the powerful tech giant we know today. The evolution of Nvidia. The 90s were marked by buzzing TV screens, dial-up internet, and beige computers. Those who grew up in this decade witnessed the evolution of personal computers. In the early 90s, displaying a file browser window or opening blocks of text was virtually all the graphic processing required. CPUs were powerful enough for these tasks, unless you were working with animation or engineering, where more complex graphics were needed. For those seeking advanced graphics, video game consoles were the ideal solution. However, a trio of engineers, Jensen Huang, Chris Malachowski, and Curtis Preem from sunny California, had a different idea. They envisioned a separate hardware processor that could easily bring more powerful graphics to personal computing. Their discussion sessions in a local restaurant, fueled by endless cups of coffee, led them to a critical conclusion. CPUs, as the heart of computers, were designed for serial processing, capable of performing only one task at a time. However, generating 3D graphics for games required repetitive and math-intensive tasks, which overloaded CPUs. Their solution? A separate chip capable of parallel processing, a game changer in computing. This chip would divide complex tasks into smaller tasks and execute them simultaneously, significantly boosting efficiency, especially for tasks like rendering 3D graphics. This innovative chip, which would later be known as a GPU or graphics card, wouldn't replace the CPU, but would complement it for graphic tasks. This idea laid the foundation for Nvidia and would revolutionize not only computing but also computer science over the next 2 decades. However, at the time, Nvidia's focus was squarely on enhancing the gaming experience on PCs, a market with immense potential. Thus, in 1993, in a condo in Fremont, California, Nvidia's journey began. The company was founded with the innovative concept of integrating parallel processing GPUs into home computers. Interestingly, the name Nvidia is a blend of NV, an acronym for Next Vision, and Invidia, which means envy in Latin. The choice of green in their logos, a color associated with envy in the United States, symbolizes the emotion they hope to evoke due to the immense computing power their chips would provide. The brains behind Nvidia were top-notch engineers. Jensen Huang, a Taiwanese-American electrical engineer, brought extensive experience as a director at Coreware in LSI Logic and as a microprocessor designer at AMD. LSI Logic played a crucial role in Nvidia's early journey. Alongside Jensen Huang, the co-founders of the company included Chris Malachowski, who brought his valuable engineering experience from HP and Sun Microsystems, and Curtis Preem, a former graphics chip designer at IBM and Sun Microsystems. While having skilled engineers was advantageous, launching a new company from scratch brought its own set of challenges, as the founders of Nvidia soon discovered. In 1993, they found themselves at a crossroads, unsure of how to proceed. Seeking guidance, they enlisted the help of a lawyer to assist in founding the company. With just $200 in hand, Huang took a bold step, investing his modest amount to kickstart Nvidia's journey. This initial investment not only paved the way for the company's foundation, but also secured Huang a 20% stake in Nvidia. The next hurdle was securing funding to fuel their ambitious vision. From skepticism to success. Convincing venture capitalists turned out to be a tough battle. Instead of sophisticated business plans, investors looked for founders with a track record of success and a compelling vision. Despite the challenges, Nvidia finally caught the attention of investment firms Sequoia Capital and Sutter Hill Ventures, securing substantial funding of $20 million. This level of funding might seem extraordinary for a startup. However, it was Huang's previous connection with LSI Logic that played a key role. Leveraging his ties with the CEO of LSI Logic, Huang arranged a meeting with Sequoia Capital, a venture capital firm that had already invested in LSI Logic. Despite initial skepticism, Sequoia Capital eventually bet on Nvidia, recognizing the potential of the growing graphics card industry. This initial investment of $2 million was followed by another $18 million, propelling Nvidia towards future success. At that time, deciding to invest in Nvidia was a risky decision. There were 89 other companies pursuing similar goals, but only AMD and Nvidia managed to survive the competition. When Nvidia went public in 1999, Its value soared to $600 million, making the initial investment pay off handsomely, multiplying it by an impressive 100 times. But let's not get ahead of ourselves. At this point in history, Nvidia was just a small team of engineers. With funding in hand, it took 2 years to assemble a team and develop their inaugural product, the NV1. Officially launched in 1995, the NV1 marked Nvidia's entry into the market. During the development phase of the NV1, Nvidia secured a deal with Sega to produce chips for their gaming consoles. These chips were created for popular games like Virtua Fighter and Daytona. Interestingly, the NV1 chips were also compatible with computers, allowing players to enjoy Sega Saturn games directly on their PCs, a revolutionary concept in 1995. Nvidia made a bold choice by adopting a square-based image rendering architecture for its NV1 chips, a decision that did not make Sega very happy. Despite Sega's objections, Nvidia's leaders stood firm, refusing to alter their plans. But why did they opt to render polygons in squares instead of triangles? The rationale behind this choice is explained in a video by Lazy Game Reviews. Using squares instead of triangles was intended to speed up rendering by alleviating CPU load. In theory, this approach meant fewer polygons and better rendered rounded objects. It offered flexibility to create shapes with squares, instead of being restricted to triangles in all cases. This strategy made sense at a time when CPU speeds and memory times were relatively low, as it provided enhanced rendering for certain objects or models in games. However, as technology advanced and memory capabilities improved, this approach became less practical. Moreover, there were compatibility issues, as there was no support for OpenGL, a widely used graphics API. Nvidia and SGS Thomson even expressed skepticism about the relevance of OpenGL for consumers. Additionally, when DirectX and Direct3D emerged, rendering NV1 through squares presented further limitations. Nvidia attempted to address this with a software update, allowing NV1 to run DirectX but only in software mode, negating its hardware acceleration capabilities. Despite its innovative approach, the NV1 project failed to make a significant impact. Its goal was to be a versatile solution, combining 3D graphics, video, audio processing, and more in a single chip. However, as Huang later stated, the NV1 was akin to an octopus, complex, multifaceted, and possibly ahead of its time. In the end, the chip failed to capture the market's attention. The market demanded something simpler, a dedicated 3D graphics card, not a complete solution like the NV1 chip. Additionally, the NV1 was perceived as too expensive compared to its competitors. To make matters worse, the industry was shifting, with Microsoft introducing DirectX, a new API that favored a triangle-based standard for rendering 3D graphics. This made it easier for developers to code graphics, leading them to adopt DirectX. Unfortunately for Nvidia, the NV1 chip was incompatible with DirectX, causing many existing games to suffer from performance issues or become unplayable on the new Nvidia chip. This incompatibility was a significant blow to the company, with their client Diamond Multimedia returning the vast majority of the 250,000 NV1 units they had purchased due to poor sales and lack of game support. This return nearly drove Nvidia to bankruptcy, resulting in the layoff of 40 of the 80 employees and leaving them with a surplus of idle chips. It was a disastrous situation, totaling a loss of $10 million. Amid this turmoil, Nvidia was developing the NV2 chip for Sega, which was also based on the outdated Square architecture. Recognizing the need to make changes to survive, Huang took a bold step. Advances and transformations of Nvidia. Huang approached the CEO of Sega with a request to be released from the contract but with full payment. This money was crucial for Nvidia to stay alive. In an act of extraordinary kindness, the CEO of Sega agreed to Huang's request. This generosity allowed Nvidia to redirect its focus and resources towards a path aligned with the industry's direction. If Sega had withdrawn its investment at that critical moment, Nvidia would have been extinguished. Nvidia's experience with the NV1 was a crucial lesson in their journey. It highlighted the importance of understanding customer needs and market trends, shaping Nvidia's future strategy. It's remarkable how close Nvidia came to failure, especially considering its current value of over $1 trillion. However, The decision to heed market feedback and focus on personal computers marked the beginning of its extraordinary success story. After so many problems, Nvidia decided to return to the chip industry with a more direct approach. The timing was ideal, with the PC market flourishing. In 1999, Nvidia released the GeForce 256 graphics card, which was not just a success, it transformed the industry. As the first programmable graphics card, it also popularized the term GPU. This innovation allowed players and developers to explore new creative paths with shading and advanced lighting effects, significantly elevating the gaming experience. Leveraging this success, Nvidia went public the same year. In 2000, they secured a significant deal to develop graphic hardware for Microsoft's Xbox gaming console. This deal provided Nvidia with a substantial advance of $200 million, a considerable jump compared to previous console efforts with Sega. The Xbox debuted in 2001, equipped with a specialized chip known as NV2A, tailor-made by Nvidia. This success served as a springboard for Nvidia's prosperity throughout the 2000s. They played a key role in shaping the processors for Sony's PlayStation 3, while also catching the attention of major players in the computer industry, such as Apple, Dell, and HP, who began incorporating Nvidia GPUs into their products. The company's growth trajectory seemed unbeatable, thanks to a combination of strategic decisions and innovative technologies. One of the key strategic moves of Nvidia was positioning itself as a fabless integrated manufacturing company. But what does that mean? Essentially, fabless chip companies design the chips, but outsource their manufacturing. Huang was adamant about this approach, seeing it as a way to significantly reduce costs. Over the past 3 decades, Nvidia has partnered with Taiwan Semiconductor Manufacturing Company, or TSMC, the world's leading semiconductor company. The state-of-the-art manufacturing capabilities of TSMC have been crucial for Nvidia's continued success. As Huang himself acknowledges, Nvidia owes many of its achievements to the pioneering work of TSMC. While Nvidia focused on chip design, outsourcing manufacturing allowed it to channel resources towards innovation. They broadened their horizons beyond chips and gaming graphics, recognizing the immense potential of GPUs and their parallel processing power. Nvidia aimed to empower developers with the tools and software necessary to unlock all the capabilities of the GPU. In 2006, they launched CUDA, a software toolkit that revolutionized parallel computing, leveraging the power of GPUs for a wide range of applications. Before CUDA, programming a GPU was quite complicated and daunting for programmers. It involved delving into APIs or complex low-level languages, which was often a headache. However, CUDA changed the game, making it much simpler to write programs that could utilize the power of the GPU using familiar programming languages such as C, C++, and Java. This innovation had a profound impact, extending far beyond graphic applications. It opened up potential for various sectors dealing with large amounts of data to harness the parallel processing power of GPUs. The trend gained momentum in 2008, when the Tokyo Institute of Technology used CUDA-accelerated GPUs in its supercomputer, achieving remarkable performance. Since then, many other data centers, including Amazon Web Services, Google Cloud Platform, and Netflix, have adopted GPUs for various applications, such as cloud computing, machine learning, video streaming, and web searches. However, the real breakthrough came with the explosion of AI in 2012. The GPU revolution. A critical moment came with the emergence of AlexNet, an innovative deep learning neural network. Developed by Alex Krzyzewski, a doctoral student at the University of Toronto, AlexNet leveraged the power of GPUs to significantly enhance computing efficiency. By connecting 2 Nvidia GeForce GTX 580 gaming cards to his computer, Krzyzewski processed the AlexNet neural network with an extensive dataset of 1.2 million images. The results were astonishing. The image recognition accuracy showed a notable improvement, with an error rate of 15% compared to 25% from the previous year. While these numbers may seem modest by today's standards, it was a significant milestone at the time, laying the groundwork for the sophisticated AI tools we now take for granted, such as ChatGPT, Google Gemini, and Google Lens, which feature much higher accuracy. At the time, this event was nothing short of revolutionary. It marked the beginning of a new era, breaking long-standing skepticism around neural networks and ending what became known as the AI winter. For decades, experts dismissed the practicality of neural networks, but the success of this event proved them wrong. The Nvidia GeForce GTX 580 cards played a significant role in this revolution. Optimized for CUDA, they paved the way for the implementation of parallel algorithms, making them indispensable for deep learning tasks like those performed by AlexNet. Suddenly, a vast array of possibilities in deep learning applications opened up, and Nvidia was at the forefront of this transformative moment. Their strategic investment in CUDA and the software ecosystem began to yield significant results. Nvidia GPUs quickly became the gold standard for training and deploying generative AI and large language models. For example, OpenAI, known for ChatGPT, relied on Nvidia's A100 series GPUs for the rapid and widespread deployment of its AI models. Following the sensational debut of ChatGPT in November 2022, major tech companies rushed to acquire Nvidia GPUs, triggering an explosion in demand. The A100 GPUs, in particular, flew off the shelves. Microsoft alone purchased an impressive 10,000 units. Each A100 unit came with a hefty price tag, $110,000, but Nvidia sold hundreds of thousands of them. The unprecedented demand drove Nvidia's sales to skyrocket to $13.5 billion in the quarter ending in July 2023, marking an impressive 101% increase from the previous year. On May 25th, its stock market value soared to $184 billion in just one day. And on May 30th, 2023, Nvidia achieved a monumental milestone by becoming the sixth company in the world to reach the coveted market value of $1 trillion. Today, Nvidia's market value exceeds $2 trillion. What do you think of this new technology from Nvidia? Leave your opinion in the comments below. If you enjoyed and learned something new from this video, don't forget to like and subscribe to the channel. Thank you for watching, and see you next time.